Hi friends, welcome to our Python basic session, and we are continuing our learning on functions. So we have continuing, this is the fourth session on functions. So still yesterday we had discussed about recursive functions and how to use it, and we have also studied the factorial of a number, how to get it using recursive function. So after that we'll not move to other topics. We'll practice a little bit on the recursive functions. And one thing we left it, what is the system setting on recursive? Will it allow infinite recursive? Means the function is calling itself, means somewhere you had to stop it. Okay, programmatically we may stop it based on certain conditions. The call for recursive function will stop. But say if we miss that, then will the system allow us continuously run, and the system will hang in that way. That's why there is a system setting. We'll see that. But before we move, again my request is please subscribe to our channel and press the bell icon so you'll be notified as and when we are adding new tutorials, and we are coming live also. And please share this with your friends also. Let's start it. But before we start, let's go to our Colab platform. So here we are in our Colab platform. So in this, it's a Google Cloud platform. You can also use it. You just need a Google ID for that. It is not necessary that you should use your Colab platform only. You can download it from here. You can, as you can see here, you can download IPO Jupyter notebook or .py file and use your ID, whatever in your local system you are using. Same one you can use it to run the Python file. Here it is Colab we are using because for the basics you can easily share the file. At the top you will get a share button, and I hope everyone will have a Gmail ID, so easily we can do it, and our files are stored in our Colab against Google Drive, against our Google account. So let's just quickly see how this one works and where you can download the source. So here it is, this file, this particular URL is available in the description. You can visit that. The entire source code is here. Whatever we are discussing here, that is entirely available. And you can scroll down, come down. This is yesterday what you had discussed about the factorials, and this image we have added today. So you can understand the while taking the factorial. 5 factorial is 5 multiplied by 4 factorial. Then this 4 multiplied by 3 factorial, like that it goes, and from the backward it starts coming. That's how the recursive functions works. Now let's scroll down here. Here you will get a GitHub link. So once you click that, you will be taken to GitHub. The entire source code is there. You can download it. Everything you can do. Let's just see whether you will also get a Colab button. So where by clicking that directly you will go to the your Colab platform. So during this time, here the button will be at the top. You can just let it load. It's taking more time to load. So in the, I think this time 2 days back also we faced some problem. So this file is there. You will get a button at the top. Click that and go to your Colab platform and start using it. Now let's come back again to our, here it is everything. And one more thing, there is a set of questions for questions on function. Here it is. Let me close this. Here it is. So this function questions you can try it. This will help you in understanding. And if you are facing any issues or anything, put it in the comment section. You can do this URL also. It is linked from here at the bottom. You will get it, and this link is available. All our online classes, sessions, everything links are there. You can use that one. Here it is. Questions on that. So use this URL to reach here. Now let's come back to our Colab platform. In this Colab platform we'll be using, first let's start with get recursion limit. So let's start with the code block. So this is the one. Now what I am going to do is import sys. This is a system file I am importing because I will be accessing some system data. So this library I am using it, this modular library. Now what I am saying, print what is the present system limit. So sys system dot get. Now this is get recursion, recursion limit. So this will tell me what's the print the present recursion limit setting for the system. So let's just run this and see. It's 1000. That means 1000 recursions. Yeah, 1000 recursions it will allow. Beyond 1000 it will stop. So even if you create a say here we are returning the result, we have put a condition n equal to 1, then you come out, that is come out of the recursion. That's what condition. Say you miss that, then up to 1000 recursions it will allow. Now can I change this one? Yes, we can change it. So we'll say we'll give a sys dot now set your recursion limit. Now let me set it 2000. Now what I will do after this line, I will copy this and pasting it. Now let's say what's the system, this thing I have changed it to 2000. So let me run this. Yeah, you can see this, the fourth line gives me the output of 2000 because I have changed it. This is the system setting for recursion, putting upper limit of number of recursions from I can multiple calls to the function or recursion calls. So that is the upper limit. I can change that also. So that's what is there. So let's close this. Okay, now these two will practice. Now why we are, because it is better once we practice this, we'll come to know about the how the recursion function works. It is simple if it is, while explaining it's very simple, but while doing it you will get lot of doubts. That's why practice this particular one. Now let's take it sum of digits of an input number. This, there are many ways of doing this also. Here you will get all the links also. These are the links are there. If you come down here, it is sum of digit and you can check that where you will be. And one of the ways using recursive, that particular part, because other things also, while loop, for loop, whatever is there, you can try that one. So let's use a recursive function only. Using recursive function, we'll try this. There are other ways are you can use a while loop also, enter a number. So it's a string. You just loop through each and every digit and sum it up. It's very simple. But we will try the recursion because our understanding of recursive functions to improve. So for that, let me just add a block here, start it. So n is my input number variable, I will store it. So once I am taking the input, I have to convert into an integer because by default all inputs are string. So now I will say input. Now what I am going to write is enter a number. So user will, whatever the user enters, it stores in our variable n, but it's an integer now. So we have given int here. Now, so let's declare a variable total. So sum of the digits, so somewhere you have to store it recursively, we will be adding to it. So total I am keeping it at 0. Now def, or defining a function, my sum. Let me put n here. Okay, inside this function, what I am going to write? I will first access the global value. Now what is a global, what is a local? We will study it more. So total means don't use your own local parameter. Every time you call it, this is, if you in the C, if you have knows about static variable, it is similar to that, because even if I come out of the loop and go enter into there also, the total value will be there. So it will not start fresh. Fine, that is why I have given that. Now I am saying if n is less than or equal to 0, fine, I have given then return. Then return 0. Okay, else. Else. Now here I am taking n modulus, means what it is going to do. Reminder of this division is here, it is, this is will take it, say I have say 109. So I will divide it by 10. So remainder is 9. So that 9 I will hold that value. So that is it. This is the modulus or the remainder of a division. Now let me fine, its comment I have written there. Now the total, because my purpose is, say input number is 572. So I purpose is 2 plus 7 plus 5. So first by dividing I am taking out the 2. So adding it to total. Next time I will divide, I should divide 57 I will take. So that is the purpose. Now you just see how I will get the 57. Now total is total plus I value, because one digit, rightmost digit I have taken out and added to total. Fine. So now n value I will change. N equal to n What does this mean? This is the floor value of the division. Means so we have a remainder separately, and what is the floor value? Floor value is suppose it is 125, 125. Now I am dividing it by 10. 5 is the remainder and I will get 12. 125 means divide by 12 by 10 means I will get 12. So that is the floor. 12 is the floor value. Now n value I am changing it 125 to now it is 12. So the rightmost digit is taken, 5 is taken out. Now the value is also 12 now. Now what I am doing, I am calling the recursive function now, my sum n. See this, here the pointer will jump from here to this. So because now n is, initially the n value is 125, say I have entered. Now the value second recursive function call, it will take 12. Okay. Now once all the calls are over, now I will return total. That's all, my function is ready. So I will say print sum of digits in number, digit in number of the number. Okay, fine. Now here I am saying my sum. Here I am calling the function with n. Say what happened, input number I have taken, this n will jump here and sum of the number. Now it will call the my sum function, and inside this here is the recursive call. Let's try it first. I am just moving up a bit. Enter number 1, 2, 6. I have entered. Let's see. 6, 2, 8, 9. Sum of the digits of the number equal to 9. So this is, there are simpler ways of doing this. It is just because we want to know the recursion. Other things also using a digit while loop, just half the line of we can finish this code. But here we are trying to understand the recursive function, and that is our purpose why we are using that. So this is, let's try one more. I am 1005. I am intentionally keeping a 0 also, so it is, see, the number is 5. Now suppose I start at 007, because the first itself, once it is converting to integer, it will take care, so it will remove that, keep the 7 only. So sum of the digit is 6, even if I use, so 0 is also taken care. What has happened, first 5 is taken, next 100, next 10, then 1. So once it is less than that, because when it is 1, when it is divided by 10, it will return 1 only, because now the n value will fall below 0, so it will come out. So this if condition will take care of that, and else part we are anyway calling it again. And finally, once this is over, return is total value, whatever the sum of the individual digits. So this is the use of recursive function. Now, okay, now this is a little different. So in your math sessions, you must be studied about the greatest common division and lowest common multiple, all these math functions. Now we can use Python to get that also. Fine, there is a page is there where all the ways, while loop, for loop, everything is there. But let's see how the recursive, using a recursive function, will get that one. So it is there are different ways. In fact, there are built-in math mod functions are there, but you have to import the math module. Here what we are trying is, we are not calling it math functions again. We are just using a recursive function to get the GCD. Then LCM also, LCM we will get it, we will take the GCD value, then do a multiplication. That we will see. So let me just add that. Anyway, the other codes, other ways how we will get that also, that is available. You visit the URL in the description, it is there. You can just by using while loop, all these things are available. Now a equal to, again, integer, then input, what I am inputting, enter first number. Okay. Enter second number. I am just copied it and using. Okay, so I have two integers now, two numbers I am using. Now let me just write the function how I'll get. And this is, by the way, this is known as Euclidean algorithm. I think probably if you would have in the math classes you must have studied this. The Euclidean algorithm repeatedly replaces the large number by the remainder of dividing the large number by the smaller number until the remainder is 0. The last non-zero remainder is the GCD of the two numbers. So that is the concept. Same thing we'll use it by using this recursive function. So we'll define GCD. We are taking a comma b, two inputs values we are taking into our function. If b equal to 0, it's a comparison operator, not an assigning operator. So it will check whether b is 0 or not. It's a comparison operator. Two equal to's. Single equal to means assigning. Okay, return a. Else return GCD. GCD, here I am saying b, but here is the one, a modulus b. The a modulus b. Fine. Here is the function. That's all. This does that Euclidean algorithm, that what it is used. It calls again, but this time b, you just see the places are changed. So an a modulus b, the remainder is taken. So again b is checked. Like this is the recursive function call. Now what I am going to do is GCD. I am uppercase I am writing, and variables are case sensitive. Knowingly I have GCD. Okay. So GCD value I am saying is GCD of a comma b. So this is calling the function. Here is GCD, or if it is confusing to you, you use my GCD also. Here everywhere you have to use my GCD, and this holds the GCD value, or greatest common divisor value. Now let me just print the value is print GCD is, sorry, I have to put quotes here. GCD is GCD. GCD is the variable. So let's run this. You can do anything. Let me just 85, enter. Now second number 20. GCD is 5. So this is how we will get it. Now let me run one more time. 125, fine. 75. So what is the GCD is 25. So this is the greatest common divisor is 25. So this is how we'll get. Now let's come to LCM. So LCM, there is a slightly different concept is used. Okay, I am here. I will use a while loop to get the GCD. So little long it will be. Okay, too quickly we'll finish that. So LCM. Okay, now I am getting same two values I am taking, defining a get GCD. So GCD. Now here I am telling x comma y, two numbers I have taken. Now here I am using while loop. While y is not 0, that means y I am checking in other way. It is true. While y. Now x comma y equal to y comma x modulus y. This is the same as you just see here. More or less you can understand this. X will take the value of y and y will take the remainder of x by y. That is that Euclidean algorithm what we are. It's a shortcut way of writing it, and continue this till y is not equal to 0. Means y value is available. While then return x. So x holds the GCD value. Now outside this we'll one more take, because now I got the x value. So def get LCM. Now here another thing we are running. We are calling one function inside another function. We'll see that. Get LCM. Now what I am taking is x comma y, same two input numbers, putting it here. Now LCM equal to, just watch what I am doing, ABS absolute value of x product y. This is multiplication. Now the floor value here I am doing is get GCD. Get GCD is the function here. Let me just give a gap so you can easily understand. Sorry, not here, here. The above, let me move up also. Get GCD. Now once I get GCD, I have to pass the values. So x comma y. Now this is the main one. Now return LCM. That's all. So what I am going to do is, okay, I will just write down num1, number 1, integer. Now I am telling input, enter first number, fine. Oof, I missed the quotes again. Sorry, let me put the quote here. Okay. Now num2 equal to int again, input. So second number I am asking. So two numbers I am taking from the user. Now I will print directly, telling all the thing. I will call the my main thing is these two input numbers. I will call this particular function. Then internally it will call the function and show me the result. So I am writing it in a print, inside a print command. So print the LCM of, now here I am giving comma, so variables I will print it, num1. Now and is again a string, so I am saying and. Now here num2, second number, this is a string only so far, num2. Now again is, so string again is a string, is get LCM. Get LCM is line number 6. You can see the function, and here I am passing my two numbers, num1, num2. Okay, that's all. So no, here this LCM it should be, okay, this is a string only. LCM of num1 and num2 is get LCM num1. So this, there is no error, already 23. Okay, fine. Enter the number, let me enter 20, let me enter 12. LCM of 20 and 12 is 60. So this is a full sentence is printed. This is the last line. So 11th line, and here I am calling the function. This function I am calling it here. Let me just give a gap here. So that's all. So this is the way the recursive functions are frequently used. So you can use it, just practice it. So we'll saving this, and I will put it in the GitHub, this particular including whatever yesterday. Now the same file we are continuing. This became a little bigger also, no problem. You can download it. I will add some comments. I will write it. So it will be easy for you to understand it. So before we conclude, my request is please subscribe to our channel and press the bell icon. And we are coming frequently online also, and next week also will be, but there will be a slight change in the schedule. I'll let you know. I'll post it in the board there, so you can easily know. And if you feel somebody will be benefited by these sessions, please share this with your friends. And let me just see if any questions are there. टिकटर का प्रोग्राम करें, श्योर बेसिक से कोडिंग में सर जी एक सब्सक्राइबर काम होगा रेस्पेक्ट सर डिक्रीज नो. ओके, सो फाइन, देयर इज ए टिकटर का डिमांड है. ओके, विल सी दैट वन. Probably next week I am thinking that will change little bit and work one day will start Kinter and one day on basics, and if possible we'll go towards web development and PHP and database management also. And if you have Ticketer basics say, okay, sure, Ticketer will start. I think many people, probably I can assure you, so Monday and Tuesday I may not able to take the session on Monday, Tuesday. Wednesday, if possible, one day we'll start with Kinter, and I will give you advance information also, or Thursday. So next week, one session Kinter must. We'll start from the very basics. Hopefully, it's Kinter. You just install it, Kinter. Then we'll start. Create a button. The first thing, a label, a button. Click the button, get the data, and also while using Kinter, we will connect to database, pull the data, so you can create some small applications. Tell me what more you want, because coding world, because I have unsubscribed. Okay, you can tell me what is your issue, why the coding world has unsubscribed. Okay, you can tell me what you want and what is your problem. And if you have any other idea, okay, thank you to see. Namaskar sir, coding world, because I advise her to speak Hindi. Yesterday I remember there was a Hindi. देखिए मेरा हिंदी इतना अच्छा नहीं है, बट मैं कंफर्टेबल हूँ. थोड़ा इंग्लिश वर्ड उसमें एक दो रह जाएगा, आपको वो थोड़ा मेरे लिए मैनेज करना पड़ेगा. तो मैं इतना अच्छा हिंदी नहीं बोल सकता हूँ, बट काफ़ी अच्छा है, आप समझ सकते हैं. तो एक सेशन, आई थिंक एक सेशन में अगर हिंदी में होने से देखते हैं कैसा रिस्पॉन्स है. यस सर, हिंदी. आई डोंट नो व्हाई. मेरा हिंदी चलेगा, मेरा इतना अच्छा नहीं है, लेकिन आराम से बोल सकता हूँ, मेरे को कोई प्रॉब्लम है. सुनने में तो कोई प्रॉब्लम नहीं है. ओके, बोलिए मेरा हिंदी कैसा है. यहाँ पे पाइथन में मैं बहुत सारा हिंदी सेंटेंस में थोड़ा इंग्लिश वर्ड्स तो रहेगा, उतना आप लोग मैनेज कर लेंगे, मैं उम्मीद करता हूँ. ठीक है, नेक्स्ट वीक हिंदी में रखते हैं. तो और कुछ है. कोडिंग वर्ल्ड, यस सर, यू आर हैप्पी नाउ, फाइन. सो या बोलिए, और क्या कुछ ज़्यादा एडवांस है यार, आई शुड बी स्लो. क्या आपको कैसा लग रहा है, थोड़ा और स्लो बताने में आसान होगा? मैं एक्सपेक्ट कर रहा हूँ कुछ क्वेश्चंस. ओके, आप मुझे कभी भी मैसेज कर सकते हैं. मैं सोच रहा था बेसिक्स थोड़ा और कंटिन्यू करूं, बट आप सब लोग लगता है बेसिक्स बहुत अच्छा से मालूम है. सर, एक सब्सक्राइबर की बढ़ेगा, ये सब्सक्राइबर इंक्रीज टुमारो. नाइस सर. ओके फ्रेंड्स, थैंक यू. एंड मेरा हिंदी को थोड़ा मैनेज करेंगे आप लोग, वही उम्मीद करता हूँ. मैं कोशिश करूँगा हिंदी. अदरवाइज पैरेलली और एक सेशन में इवनिंग से 7 to 7:30 हिंदी, देन 8 o'clock इंग्लिश. 20 मिनट्स काफ़ी होता है, बिकॉज 10 मिनट फिर क्वेश्चन आंसर. ज़्यादा आधा घंटा 1 घंटा लेने से डिफ़िकल्ट है. प्रैक्टिस करिए, आपको सारा सोर्स कोड एवरीथिंग इज़ अवेलेबल. इंटायर सोर्स कोड आप डाउनलोड करके आप प्रैक्टिस करिए. सो प्रैक्टिस करने से क्या है, वो डाउट्स आता है, आप इट्स इजी टू अंडरस्टैंड, बट जब आप खुद करेंगे तो आपको डाउट्स आएगा, तब आपका योर लर्निंग विल बी फास्ट. अभी बोर्ड चल रहा है, सो कुछ दिन अटेंड नहीं कर पाऊँगा. ओके, नो प्रॉब्लम. ये तो रिकॉर्डिंग तो रहता है, आप कभी भी आके कर सकते हैं. बोर्ड चल रहा है, ठीक है. मेरे को जो याद है, बोर्ड में भी पाइथन प्रोग्रामिंग है शायद. बोर्ड चल रहा है, सो नो प्रॉब्लम. सारे रिकॉर्डिंग्स रहेगा एंड मेरे लिए भी प्रॉब्लम नहीं है. मैं थोड़ा नेक्स्ट वीक में मंडे ट्यूसडे थोड़ा ट्रैवलिंग में रहूँगा. सो मंडे ट्यूसडे डेफिनेटली मैं ऑनलाइन नहीं आ रहा हूँ. वेडनेसडे मॉर्निंग आ जाऊँगा. वेडनेसडे इवनिंग अगेन आई विल, अगर मैं थोड़ा टायर्ड नहीं हूँ तो अगेन वेडनेसडे, अदरवाइज थर्सडे से पक्का. ओके, तो आज का सेशन यहीं पे क्लोज करें. Shall we close today for thing? If you don't have any other question or anything, और तो कोई क्वेश्चंस नहीं आ रहा है. आप और क्या सीखना चाहते हैं? से आप वेब डेवलपमेंट, एक्चुअली वो मेरा फेवरेट है, वेब डेवलपमेंट एंड PHP. एंड अगर आप you can connect to MySQL database, SQLite database, all these are important. Java, ICSC Java. ठीक है, देखता हूँ ICSC Java को मैं सिलेबस एक बार देख लेता हूँ. मेरा पाइथन ही वही. Okay, we'll continue Python, Kinter, SQL, database connection, PHP, everything. Java थोड़ा टाइम लगेगा. बहुत बेसिक लेवल ऑफ पाइथन एंड SQL भी बोर्ड में. ठीक है, SQL भी बहुत सिंपल है. आप यही कोला प्लेटफॉर्म में आप SQL भी यूज कर सकते हैं, क्योंकि मेरा कुछ वीडियोस भी है, आप देख सकते हैं. ठीक है, आप ओके, दैट्स ऑल. थैंक यू फ्रेंड्स. प्लीज सब्सक्राइब एंड शेयर विथ योर friends and ask them to join. I am always there. Hindi, English, no problem. I can take in Hindi, take in English, no issue. Okay, thank you friends. We'll close the session. Let me write thanks. Okay, bye.